Kunal. Good afternoon.
Good afternoon,
So
Nidesh. Yeah.
let, let me introduce myself first and then we'll go ahead with your introduction. I'm Hitesh Lal, working as a data architect with 30 plus years of experience in the industry. And I have experience on Snowflake, Databricks, PySpark, and AWS cloud computing technologies and Azure. So I've been involved into the multiple industry domains like banking, healthcare, and your shipping and logistics industry. So that's a brief summary about me, my introduction. You can go ahead with yours. We'll go ahead from there.
Thank you, Nidesh. Yeah. So I'll start with mine. So I'm Kunal Chaudhary. So I have total 9 years of experience as a data engineer. Like out of those 9 years, 6 years I've worked on ETL tools like Informatica, Power Center, and PDM. So I started my career in as a data engineer with Infosys and worked with TCS as well, and currently working with Accenture. Like basically the tech stack is currently we are working on Databricks, which is for where we have created the Delta tables as a lakehouse. And also we are using AWS Glue for your ETL storage, S3 for storage, right? And one of the applications I'm using Azure Databricks as well, where we have written PySpark notebooks. So yeah, that's all about my experience. I have worked on banking, finance, and insurance domain projects till now in my last 9 years.
Got it. Got it. So can you talk about your project, latest project, one where you're working right now in detail? What is the business problem? What is the technical? What is the approach that you're taking to resolve it?
Sure. So current project is of a healthcare domain project. So like we get n number of files. Though those are related to the customers or the patients or the sales data of basically that are for the cancer medicine. So we're currently working in this healthcare domain. So like we're getting number of files that we need to process through the ETL pipelines, right? So in one of the applications, we're using AWS Glue to migrate the data from one source to another source, and then generating the click reports at the end so that the customers or business can query those reports which are which are present in the Redshift, the data which is present in the Redshift. And in one application, right? So there are because I'm handling multiple applications. So in one, I gave just an example where we're using S3 for storage and Glue for creating those ETL pipelines, so that the customer can query and see what are the medicines which are having good sales, right? And do that analysis on that part. Second is like second case, we are again having a data in an exchange bucket, right? Which is basically again the third party, which is the data which is getting from a third party. They are placing those source file in an exchange bucket, and then what we're doing is like we are have created a big file framework BDM workflow, which is calling a PySpark script, right? So that is reading those files are in Parquet format. Those are reading the files from that exchange bucket and then placing it again in multiple buckets in S3, right? So you have the data lake, so you have different a kind of a different layers in data lake, right? So raw, consolidated, business, or lake, hub, and mart, right? So we have created delta tables on top of S3 so that we can query those tables and for those asset transactions, right? So this is the second pipeline where we have used again PySpark, BDM, Databricks again, and then the click reports again. On one of the use case, we are using Redshift for your data warehouse as well.
Okay. And are you receiving the full data or increment data on daily basis?
It is full data, and some in most of the cases, most of the applications, and some of the applications those are incremental also.
And what would be the volume of the data that you're receiving on a daily basis?
So basically, on a daily basis, it is around 200 to 300 GB of data. So that's why we have around 8 worker nodes in the cluster to handle those. So the minimum size is one worker node. So it is kind of a configurable, right? You have those dynamic allocation. So minimum is one worker and max is 8 worker. And each worker node is of memory 16 or 16 CPU cores and 64 GB memory. So which comes to total 512 of memory. Yes, so we have and though out of those 8, like one worker node and one driver node is those are on demand, and the remaining 7 are on spot. As soon as like when we get those data, we use as those resources there. So that is how we are processing this volume of data.
Got it. Got it. So you have only one cluster which is on an auto scale.
Yes, one cluster, and there are 8 worker nodes and one driver node.
Okay. And what is the use case for Redshift?
So Redshift here we're using for your data warehousing, right? So once we are loading the data to the final layer in S3, that is a business layer, and then from Redshift to from S3 to Redshift, we are rolling the data. Basically, it is for your columnar-based storage where you can massively store massive amount of data, and it is your 10x faster than your other databases or data warehouse, right? So for querying also, we are querying those Redshift tables for the click reports plus for the storage part, right? So we are storing the data in Redshift.
Okay. Can you share a scenario where you optimized a slow running job, where a job was running, was taking some time, and you did some tweaking to optimize it? Can you share some details around it if you have any experience?
Yeah, sure. So in Spark, right? So you have basically when you there was one use case when we first joined two tables using our normal joins, but we realized that the job was taking a lot of time. But the data set of one of the table was small, and then the second data set was big, right? So instead of you going ahead with left join or inner join, right? So I used broadcast join where you basically broadcast the data in your worker nodes, right? So that to reduce the number of shuffle operation, right? So in that case, you make use of those broadcast join and that. Plus, there were issues where we used to get like in lower environment, our cluster sizes are not that high as compared to prod, right? So it is just one worker node and one driver node, right? So you typically get those out of memory errors or jobs are running slow. So then what you do is like instead of doing, you avoid those collect operations, right? And you basically write it to your SDFS path or somewhere, right? Instead of doing the collect operation. So that I've done to basically reduce this performance issues plus the out of memory errors.
Okay, and then how much time was reduced?
Like it was around 25 to 30% in one case, and then this out of memory error, right? So the error was not getting, but using the broadcast line, around 30% of time was saved. Yeah.
Got it. What are the different types of facts in ETL?
In ETL, we have basically ETL. It stands for extract, transform, and load, right? So extract when you extract the data, transform is applying the transformation and then loading the data, right? So in the fact tables are basically we have semi-additive, additive, and non-additive types of fact tables, right? So semi-additive where there are some of the dimensions which can be added, and there are some which are not, which cannot be added, right? In non-additive, there are dimensions which cannot be added itself, right? So there are like examples, you have ratios and percentage which cannot be added, right? And additives where your those dimensions which the attributes can be added, right? So you have the sales amount, you have you can do some aggregation, max, min, sum, right? So those are the these are the three types majorly of the type of facts in ETL.
Got it. Got it. And within ETL, what is slowly changing dimension?
So slowly changing dimension is a concept, right? So basically, when you have a certain dimensions which evolve or changes over time, right? So like example, a customer address, right? He does not changes frequently, right? So it changes over time, right? So those are slowly changing dimension. In ETL, we have majorly three types. Those are type 1, type 2, and type 3. In type 1 you just maintain the current version, right? So you remove or delete the older data and just maintain the current version, right? Suppose in case a customer is his recent address, you just mention the recent address, you don't need the previous address, right? So in that case you'll use STD type 1. And in type 2 you basically track all the history of the customer, right? Suppose in case you want to track all the mobile numbers that the customer had, right? So in that case you will use SCD type 2. So generally we add certain columns like flag or versioning, right? Which basically helps us knowing that okay, this particular record has changed over time, there are inserts or updates in this table, right? You maintain that. And in type 3 you maintain generally The current version plus the last version, like the previous address and the current address only. Yeah, so these are the three major types, and you, depending on the use case, you implement those types.
Okay. How would you collect and aggregate the data from multimedia information, specifically with unstructured data from videos?
Okay, so dealing with unstructured data, right? So you have a number of libraries available in PySpark, right? So in my project currently, I'm not basically dealing with the video data, but like I'm aware of the concepts. So how we handle is like you basically extract the audio from your video, right? So basically, you convert that video into frames, and then you can make use of basically PySpark machine and lib libraries, and there are basically TensorFlow also you can basically use to extract the data from your video, right? So these are the methods or basically type which we can use to basically process your video data or to extract the data from your video, right? You can also segregate into parts, right? You can extract only the audio from the video, right? So these are the different ways through which you can do it.
Got it. Got it. How's your understanding about PySpark internal architectures?
Yes. So yeah, yeah. So PySpark, right? So basically in Spark, right? So you have majorly the concept of your driver node and worker nodes, right? So driver node, your it acts as your brain, right? So it acts as a brain where it handles basically the metadata, what all operations will be happening on your data nodes, right? But in your data nodes, the actual computation happens, right? So whenever you write any code in Spark, it gets and submitted as an application, right? So that application gets basically we call it a job, and those jobs gets divided into stages, and then again stages are divided into tasks, right? So and these tasks are nothing but the partitions, right, which are running parallelly. So in each of the data node you can have multiple partitions which are running parallelly, and they have their own CPU cores and the memory, RAM memory, right? So that's why like it is in Spark you have those parallel distribution, massively parallel distribution, because your all your partitions are running parallelly at a time. So that's why and Spark is your execution engine, right, where you can make use of your STFS for storage, or data lake S3, or your Azure Data Lake Gen 2 for storage, right? So these are the various storage layers available, and your Spark is your basically execution engine or a open source framework, right, which is basically work on this driver node and worker node concepts. And PySpark and this thing are these are the data frame APIs, which are higher level of APIs, which you can use to basically write your code and basically make use of Python in Spark. Yeah, so these are the higher level of APIs which are more optimized as compared to RDDs.
Got it. Got it. Moving ahead internally, how does
Yeah.
PySpark's Catalyst Optimizer improves the query performance?
Yes, so Catalyst Optimizer is a core component of your Spark SQL, right? So basically, whenever you write any SQL or Spark SQL query, right? So what it has forced, it basically works on your Scala's like very high level of programming that it makes use of, right? It makes of those functions in Scala. So what it does, it divides your um, into four phases, right? So first is the analysis part. Second is your logical plan, where it creates the logical plan. Third is your physical plan, and fourth is your code generation, right? So it optimizes your query in a bit, like suppose in case you have certain joins, right? So it kind of work as a smart brain. It optimizes your code, it optimizes your query so that your queries execute um, efficiently, right? So so this is an internal thing, and Spark SQL make use of this Catalyst Optimizer to kind of process your queries and run it faster. Yeah.
Okay. Have you ever used it? So basically, it's being used by internally, but have you ever tweaked it somewhere?
No, so basically it is because it is defaultly enabled. I have not used it as part of Spark SQL. In currently, we
Mhm.
are just running those normal SQL queries to query those table, and mostly using PySpark. data frame APIs for that. But in our project, we're just running those Spark SQL queries to view the data or check the data in the tables.
So, Kunal, can you explain me how data skewness is handled within PySpark in data distributed computing?
Yes. Yeah. So data skewness is nothing but when your data is not evenly distributed, right, across partitions. Uh, so like how PySpark handles it, right? So there are different methods through which PySpark handles, right? So one method is using the broadcast churn, right? So when you have two data sets, when where you have one data set is smaller and second is data set is bigger, right? So it makes use of you can make use of broadcast churn to do that. Plus you have the option of reducing or increasing the number of partitions, right, using repartition and coalesce, right? So in coalesce you will reduce the partition without in case you want to minimize the shuffle operation. So that is the second option. Plus you can also make use of your dynamic allocation, right? So in your static, when you're not sure of your what will be the workload, what will be the amount of data it get processed, right? When you're not sure about that, so you can make use of a dynamic location, right? Plus you have the basically the partition, right? You have the hash partitions which makes use of basically which uniformly distribute the keys, right? And then so these are the different types basically through which PySpark or Spark handles data skewness.
Okay. How are the duplicate rows handled within PySpark data frame?
In PySpark, so we have different methods to remove the duplicates records, right? We have a drop duplicate method, which you can, if you want to drop duplicates based on all your columns, so you just give drop duplicates, df the drop duplicates. But in case you want to drop the columns which are specific columns, right? So you can just drop, you can use again drop duplicate, and then you can define those columns in your drop duplicate method, right? So if just in case you want to drop duplicates from based on two columns, you can define that. Plus you can make use of your distinct method as well, right? So distinct transformation, which is again your narrow transformation, type of narrow transformation, right? So you can make use of that to delete the duplicate records in PySpark on any data set.
So we'll go ahead with the PySpark coding challenge.
Sure, sure,
Okay. I'll just ping you some data and the query around it. So can you share your screen?
sure.
Okay. So there are two columns in the data, revenue and the date. Okay.
Okay,
Maybe you can write revenue and the date,
sure.
or you can pick it up from the chat I pinged you.
Yeah.
And then the data in revenue is 2000, 3000, 45,000, 40,000. Yeah.
Okay.
So these are two columns, revenue and the date. How would
Hmm.
you calculate the month-wise cumulative revenue using PySpark?
Okay. So whenever you want to work in PySpark, right? So first, you have to basically import those PySpark libraries and basically an Spark session. So a Spark session will act as your entry point to the Spark cluster, right? So first step will be you'll write this code.
It's okay. You can explain me the pseudocode approach. That is fine. I'm
Sure,
good.
sure. So your Spark session will act as an entry gate, right? So first step will be right here. You've defined like we have two columns, revenue and date, right? And you want to do the accumulation, right? So first you will create the data frame, right? So first on this, so my first step, I'll just write maybe a pseudo code here. So first is your Spark session, this thing. Second, you'll then after that you will create a data frame. You will define the data, right? So you will define the data definition. So here you will define the data like for this thing. Uh, then you will basically define the schema, right? where you have two columns, and then you will create a data frame, right? So using create data frame method, you will create the data frame, and then after creating the data frame, then you will basically sum on the revenue, right? You will use the aggregate function to do the sum on the revenue. So you will sum on revenue, and because we are doing it like we have to do it cumulative rate wise, so you will use those order by date, right? So whenever you're doing cumulative calculations, right, so you have to make sure your date is sorted, right? So you make use of those cumulative aggregate functions, and
Mm-hmm.
you'll order by this, you'll order by date here, date column, plus basically you will generate a new column. So using with column method, so using with column method, you will generate a new column which is called cumulative revenue, and then you will generate based on your basically you'll calculate based on the sum of this revenue, right? And in case, because if it is a string column, right, so you can convert it to your date format, right? So using those other window functions,
But
right?
you're getting my point, Kunal, here. Like, add, so there will be, let's suppose that
Mm-hmm.
you have like 40,000 is with second Feb date. You getting it?
Okay. Yeah.
40,000, the date is second Feb,
Yes, correct.
and 13,000 is third. So there will be three records out of it. January, 50,000 for January, 90,000 for February, because the 50 plus 40, 90 will be coming out as February.
Okay. Yeah, we are not doing date wise here. We are doing month wise.
Month
Month
wise
wise.
cumulative.
Okay. Yes,
So
got
with
it.
January you will show me 50,000, with February you will show me 90,000,
Okay.
and 90 plus 13, that is 1,03,000 with March.
Okay,
You
so
have the
this
three
is
records.
revenue is 20,000 and 30,000, right? I think I mentioned it, maybe I missed 10. So it is 2,000, or it is okay. So basically you'll do the
No,
calculation.
I'm talking about 20, 2 and 3 only. So 2 plus 3, 5 plus 45 is 50.
Yes, correct. Okay. Got it. Yeah, the January month data. Yes. So we have three data in the January, like 45, 3 and 2. Okay. So you are doing month wise, right? So okay, here, so you'll have to do again group by month, right? So in case here add, then so here you will just add one more group by, and then you will do it based on your like first you will extract the month from the date, right? You can extract the month from the date, and then you will do a group by of your month, each month. So that's how you do it. Or you can second way, like you can basically convert your data frame. The second method is convert your data frame into a temp view, like
No,
basically,
Kunal, wait, sorry to interrupt.
yeah.
Like if you do a group by, the output would be Jan with 50, Feb with 40. You write down the outputs, what
Yes.
I'm expecting.
Okay.
50,000 with Jan, month basically.
Yes.
Okay. 50,000 with Jan,
Okay.
90,000 with Feb, and 103K with March. When you do group by, the output would be 50, 40, 30.
Okay. So if I group by month, right? If I do group by month and sum of revenue, right? Because January now has three records now, right? So if I do group by this, and I'll sum of revenue, so it should give me 50K, right?
Yeah.
Yes. So the same way, like for you are doing sum of revenue, and you are doing uh
But how will the output for February get 90K?
okay, for February we have just 40K, is it? for February. Let me
But
see.
cumulative sum definition is the sum of all
Correct.
the months.
Correct. Yes. Okay. Yeah, month-wise cumulative. Okay, month-wise cumulative revenue. Okay, so in the second month, we should get 90K for Feb. Okay, got it. Yeah. So basically, then you will store the previous month, January month data, and then in Feb, you will basically do the previous month plus current month, right? And similarly, you will store here in case you will do the group by will not work in this case, right? Because here you have to do it like in case you're doing group by for January month, this is the first case, but for February a month, right? So for February, you will have to basically uh, you will have to February month, you will have to, I think, um, yeah, for February month, you'll have to store that value in the January month, and then you will aggregate based on the last value, right? So uh, we can make use of lead or lag here to calculate a lag function here to calculate the previous one.
Okay.
Yeah. And then finally, once you calculate the previous one using those lag function, basically you'll do lag of your revenue, and then you will like count of lag of revenue, and then and for the last value, right? So like I want to see the previous value, right? And then if in case the last value doesn't exist, so you'll give one a default value here, and then you will dot show at the end to basically for those action, right? So data frame dot show.
Okay. Got it.
Yeah.
You'll aggregate the lag value column and the group by column.
Yes, correct. Yeah.
So lag value will have what?
So lag value will have the previous. It will have basically you can look at the when I'm calculating the February month, it will have the previous January month data, and it will calculate that. And when it is doing for the March month, it will store the cumulative revenue till Feb month, and it will calculate the Feb and March month. So that's how it will give.
Okay. Got it. Got it.
Yeah.
Okay. Fine. So moving ahead, if given an option, how would you redesign the architecture of your project?
Uh,
What are the changes that you will bring in the existing architecture of your project?
Yes. So in our case, right, we are still using some of the legacy tools, right? So we are still using Informatica Power Center in one of the applications. So like, but because there is like because we did phase wise, right, the migration from your legacy to cloud, right? So in case I would have kind of redesigned it. So currently, what we are doing is we kind of a replatforming, right? Kind of thing, right? It is basically you are kind of you have basically in your own house you are making changes so that you can accommodate to the cloud, right? But in case I would have been a kind of thought about this, right? So I would have created basically created a new home, like basically from the scratch, built to utilize the end-to-end cloud functionality, right? So instead of making changes in the current code and then to make it sync, so you have to do a lot of testing involved, and there's a lot of back and forth going on, and you have to redo things again and again, right? But I would have preferred kind of a doing entire rebuilding stuff, right? Rebuilding from the scratch to utilize your cloud functionality, right? You have those auto scaling options, you have a number of features available in your AWS Azure cloud. In AWS now, in Azure you have the basically data lake gen 2, right? So where you are hierarchical data storage is basically you can make use of that. So in gen when it was not there, right? So you can make of this all this of functionality which is basically for your big data storage. You can make use of your Databricks, right? So Databricks is nothing but your Spark on cloud, right? Instead of writing, so in your data warehouse you had you only had structured data, and your data lake you can only store unstructured, but you don't had those delta lake or SC transaction support, right? So you can make use of this new lakehouse architecture like Databricks so that your even the asset transactions are supported, right? So it combines both the features of your data warehouse plus the data lake, right? So data lake house is, we call it a data lake house, right? So a similar way I would have kind of redesigned and implemented the code. Yeah.
Got it. Got it. Okay. Thank you, Gana. Thanks.
Thank you, Tesh. Thank you. Thanks a
Okay.
lot.
Bye bye.
Yeah. Bye.